Far beyond Neptune's orbit, in the cold outer reaches of our solar system, ancient and mysterious worlds drift silently through space. These remote objects, cloaked in darkness and ice, were once thought to be simple and inactive, but discoveries over the past decade have proven otherwise. One such world is Pluto, once considered little more than a frozen, featureless rock. Now we know it's a dynamic and surprisingly complex world. Nearby, there's Arrokoth, a small, reddish object shaped like a squashed snowman, a time capsule from the birth of the solar system, holding secrets about how planets first began to form. What mysteries lie beneath Pluto's icy surface? How did Arrokoth end up with such an odd shape? And could something as incredible as life exist in the hidden depths of Pluto? These questions guide us into a distant region of the solar system, where new discoveries continue to reshape our understanding of planetary science. In July 2015, NASA's New Horizons spacecraft flew past Pluto for the first time. What it revealed shocked scientists around the world. Pluto wasn't a dull, frozen relic. It was geologically alive, with mountains, plains, and a surface far younger and more diverse than expected. One of the most remarkable findings was a series of ice volcanoes, or cryovolcanoes, that rise like giant domes from Pluto's surface. In 2022, closer analysis of New Horizons data showed that near the southwest region of Pluto's iconic heart-shaped plain, there are huge dome-like structures with lumpy textures. One, called Right Mons, stands nearly 5 kilometers, or 3 miles tall, and stretches about 150 kilometers, or 90 miles across, rivaling the size of Earth's Mauna Loa volcano in Hawaii. Nearby, another icy dome, Picard Mons, adds to the mystery. But these volcanoes don't erupt molten rock. Instead, they may have once released thick, slushy mixtures of water, ice, methane, and other cold substances, more like a gooey glacier than a lava flow. What makes these icy volcanoes truly surprising is their age, or rather, their youth. The surrounding terrain has few, if any, impact craters, which means it's been resurfaced relatively recently. In cosmic terms, this activity could have happened just a few million years ago, practically yesterday in the lifespan of the solar system. Some scientists even think Pluto might still be geologically active today. The idea that such a small, cold world, only about 2/3 the size of our moon, could still have internal heat seems unlikely, but the evidence suggests otherwise. So where is Pluto getting this heat from? One possibility is that radioactive elements deep in its rocky core are still producing warmth. Another theory points to the presence of substances like ammonia, which act as natural antifreeze, keeping underground water from freezing solid and allowing some of it to remain in a liquid state. Whatever the source, these icy volcanoes are a frozen reminder that Pluto is far from lifeless. During the flyby, New Horizons also detected massive cracks and troughs across Pluto's surface, tectonic features that suggest something is pushing upward from below, causing the crust to stretch and break. This has led researchers to an astonishing theory. Pluto might have an underground ocean. Buried beneath layers of rock-hard ice, this ocean could lie tens or even hundreds of miles beneath the surface. And as the ocean slowly freezes over time, the water expands, just like a bottle of water left in the freezer. That expansion could crack the crust, creating the giant fractures we now see. Curiously, scientists haven't found signs that the ocean ever froze completely. If it had, the pressure would have created a special form of dense ice known as Ice 2, which shrinks instead of expanding. That would have left the surface sagging inward, but we don't see that. When NASA's New Horizons spacecraft studied Pluto, one thing stood out. There were no signs of the planet being squeezed from the inside, something scientists would expect if its underground ocean had completely frozen. This absence of compression led scientists, including Dr. Alan Stern, the mission's lead investigator, to a fascinating idea. Liquid water may still exist beneath Pluto's icy surface. But how is that even possible? After all, Pluto is incredibly far from the Sun, and its surface stays bitterly cold, around -382 degrees Fahrenheit. That's far too cold for water to stay liquid in most cases. So what's keeping it warm on the inside? Scientists believe Pluto's rocky core and surrounding layers trapped heat left over from when Pluto first formed. That internal heat didn't escape completely over the billions of years, and part of the reason is good insulation. A recent theory suggests a layer of gas hydrates, ice combined with gases like methane, might sit beneath the outer ice shell, acting like a thermal blanket. These special ices, also known as methane-rich clathrates, don't let heat escape easily. They trap warmth, allowing the ocean below to stay liquid for longer periods. Additionally, Pluto's underground water likely contains ammonia, which works like natural antifreeze. It lowers the freezing point of water, keeping it in a slushy liquid state even at extremely low temperatures. All of this points to a remarkable conclusion. Pluto is probably an ocean world, a planet with liquid water hidden beneath a thick frozen crust. That would put Pluto in the same category as moons like Europa and Enceladus, which are also believed to hide oceans beneath their icy surfaces. But unlike those moons, Pluto isn't orbiting a massive planet like Jupiter or Saturn that can stretch and heat its insides through gravitational forces. Pluto may be sustaining its ocean all on its own. In fact, research published in 2020 suggested an even more dramatic origin for Pluto's ocean. It may have formed hot. According to this idea, violent collisions and impacts during Pluto's formation could have produced enough energy to melt ice deep inside, creating a warm ocean right from the start. If that's true, then Pluto could have held a subsurface ocean for over 4 billion years. A mind-blowing possibility that hints this distant world might have been active and potentially even hospitable for life throughout much of the solar system's history. Above this hidden ocean, Pluto's surface features a thin, ghostly atmosphere. It's mostly nitrogen with small amounts of methane, and it forms a faint blue haze, a delicate glow that New Horizons captured when sunlight shone through the atmosphere during sunrise and sunset on the planet. This thin atmosphere was another surprise. As Pluto reached its closest point to the Sun around 1989, frozen gases on its surface warmed up and turned into vapor, causing atmospheric pressure to rise.
From 1988 to 2016, Earth-based observations showed Pluto's atmosphere became 3 times thicker as more nitrogen gas was released into the sky. But now, Pluto is drifting farther from the Sun in its long 248-year orbit, and things are changing again. In 2019, during a rare astronomical event called a stellar occultation, when Pluto passed in front of a distant star, scientists measured a dramatic drop in pressure. Pluto's atmosphere had thinned by over 20% since 2016. An earlier occultation in 2018 had already hinted that the atmosphere was starting to shrink. What's happening? As temperatures drop, Pluto's nitrogen gas is refreezing, falling back to the surface as frost. If scientists' models are correct, Pluto is entering a period of atmospheric collapse. According to Dr. Andrew Cole and his team, who monitor Pluto's seasons using these stellar events, most of the atmosphere could turn into ice and settle on the surface by the 2030s. During Pluto's long, dark winters, especially when the northern hemisphere is shrouded in darkness for decades, the cold will become so intense that the remaining gases will freeze out completely, forming thick layers of frozen nitrogen and methane on the planet's crust. For a long stretch of time, Pluto may become a frozen, airless world. Its once active atmosphere will all but vanish, leaving behind a clear sky and only faint hints of vapor near the few regions touched by sunlight. But this isn't a permanent fate. Pluto goes through long seasons in its 248-year orbit, and changes built into its nature. Centuries from now, when Pluto's southern hemisphere tilts toward the Sun, sunlight will warm the surface again. Frozen gases will begin to sublimate, turning from ice directly into gas, and the atmosphere will slowly return, rebuilding itself over time. For now, though, we are witnessing a rare moment in planetary history, the gradual loss or collapse of an atmosphere right before our eyes. As this happens, the beautiful layers of blue haze seen by New Horizons will likely fade away. Oddly enough, Pluto's overall brightness might even increase during this icy retreat. That's because fresh frost, especially nitrogen and methane ice, is very reflective, and more of it is starting to coat the surface. But atmospheric collapse wasn't the only surprise during New Horizons' 2015 flyby. As the spacecraft flew over Pluto's equatorial region, it spotted something totally unexpected: dunes. Yes, dunes, like the ones shaped by wind and deserts on Earth. These ripple-like formations were found on the western edge of Sputnik Planitia, Pluto's massive heart-shaped nitrogen ice plain where it meets the towering Eldrazi Montes, a mountain range made of solid water ice. In 2018, a research team led by Dr. Matt Telfer confirmed that these dune-like ridges span across a 46-mile-wide area and run in parallel lines, much like wind-carved dunes on Earth. But these aren't made of sand, they're made of tiny grains of frozen methane. At first glance, the idea of dunes on Pluto seems impossible. Its atmosphere is incredibly thin, about 100,000 times thinner than Earth's, with surface pressure of only about 1 pascal. According to standard physics, winds in such a feeble atmosphere shouldn't be able to move grains of anything. But Pluto, as always, had a surprise. During Pluto's daylight hours, sunlight hits the surface of Sputnik Planitia, causing nitrogen ice to sublimate into gas. This sudden shift releases energy and creates rising gas currents. Scientists realize that this process can loft fine methane grains into the air, and even Pluto's weak winds, possibly blowing up to 22 miles per hour, are enough to push those particles around and pile them into dunes. The methane grains likely come from ice caps on the nearby mountains, although some nitrogen fragments might be mixed in too. Since Sputnik Planitia's surface is young and constantly reshaped by slow-moving nitrogen glaciers, it's likely that the dunes themselves are also relatively young, possibly formed within the last 500,000 years. This discovery shows that even a distant, cold world with a barely there atmosphere can still be active and evolving. Pluto's dunes are now part of a small but fascinating group of wind-sculpted features found across the solar system, alongside the carbon dioxide dunes of Mars and the hydrocarbon dunes of Titan, Saturn's largest moon. Pluto has now joined this elite club, proving once again that thin air doesn't mean a dead world. After its breakthrough encounter with Pluto, New Horizons continued its journey deeper into the Kuiper Belt, a distant region filled with icy relics left over from the solar system's formation. Its next target was Arrokoth, formerly known as Ultima Thule, a tiny, untouched object located about 4.1 billion miles from the Sun. On January 1, 2019, the spacecraft gave us our first close-up look at Arrokoth. What it found was a bizarre, snowman-shaped body, 2 lobes gently joined together in a form known as a contact binary. The larger lobe measures around 13 miles across, the smaller about 9 miles, making the total length of the object roughly 22 miles. Photos reveal the surface that is smooth, reddish, and surprisingly unmarked by craters. This suggests Arrokoth has barely changed since it formed, making it one of the most ancient and undisturbed objects ever explored. It's like looking back in time, a frozen record of how planets and moons might have first come together. One of Arrokoth's most curious features is the presence of large, mound-like bumps on the bigger lobe, nicknamed Weno. High-resolution images showed around a dozen of these mounds, each about 3 miles wide, with a similar size, shape, and brightness. Researcher Will Grundy compared it to a raspberry, a surface built from many small, rounded parts. Even the smaller lobe, called Weo, seems to have a few similar features. What's so important about these mounds? They appear to be the original pieces that built Arrokoth. Scientists believe these chunks formed gently from the same cloud of dust and gas, slowly drifting together without violent collisions. Instead of being smashed fragments, they're like siblings that grew side by side, fusing naturally over time. The way the 2 lobes align, with their poles and equators matching up perfectly, supports this idea. It suggests the objects once orbited each other closely before finally merging. The shape, chemistry, and smooth contact between the 2 halves all tell a story of a calm and careful assembly, not a chaotic crash. In short, Arrokoth offers a rare and precious glimpse into the very beginning of the solar system, showing us how the earliest building blocks of planets might have come together in deep space, slowly, softly, and with surprising order. The 2 lobes of Arrokoth are oddly shaped, flat and pancake-like, not round or spherical as you might expect. Scientists think this unusual shape may be the result of a slow, gentle merger of 2 bodies orbiting within a spinning cloud of space debris. What's especially interesting is that the color and composition across both lobes are almost exactly the same, hinting that they were born from the same patch of material in the early solar system. If Arrokoth had formed through traditional hierarchical accretion, where dust and rocks from different areas randomly collided and stuck together over time, we would expect to see more variation in its structure and chemistry. But instead, the evidence points to a more peaceful birth, the cloud collapse model. In this scenario, a dense clump of solid particles in the solar nebula collapsed directly under its own gravity, forming a small planetary building block, or planetesimal, without going through a chaotic collision phase. According to Dr. William McKinnon, one of the scientists who studied Arrokoth, the particles that formed this object likely orbited each other at low speeds, gradually spiraling inward before merging. Everything about Arrokoth supports this theory. It's a major clue in solving one of astronomy's biggest mysteries, how the first solid bodies in the solar system came together. The surface of Arrokoth also tells a chemical story. Its dim, reddish color isn't just for show, it reveals important clues about what it's made of. Data collected by New Horizons showed that Arrokoth is coated in methanol ice and a group of complex organic molecules known as tholins. These are not living things, but they are prebiotic, meaning they contain ingredients that, under the right conditions, could help create the basic building blocks of life. Interestingly, no water ice was detected on the surface, something that surprised scientists. Water is incredibly common in the outer solar system, even on tiny comets. Its absence here suggests one of two things. Either it's buried under the layer of reddish organics, or Arrokoth formed in a part of the solar system where water ice was rare or clumped into larger bodies that didn't end up in this object.
Instead, Arrokoth falls into a category of Kuiper Belt objects called ultra-red bodies, so named because their surfaces reflect deep red wavelengths. That red coloring comes from thalins, which form when simple chemicals like methane, nitrogen, and ammonia are exposed to cosmic radiation and ultraviolet light. Over time, these simple ingredients break apart and recombine into complex organic compounds, creating a sticky reddish coating. Thalins don't mean life exists, but they do mean that life's ingredients may already be present. The frozen methanol on Arrokoth likely formed either through radiation-driven reactions between water and carbon monoxide, or was part of the original icy material. Scientists also believe that Arrokoth once held other ices like methane, ammonia, or hydrogen sulfide, but these more volatile chemicals either evaporated away or transformed chemically over billions of years. What's left is a kind of organic frosted shell, rich in thalins and methanol, covering a more mysterious interior. The lack of surface water might mean there's water locked deeper inside, or that Arrokoth's birthplace was so cold it simply didn't gather much water ice in the first place. Either way, this tiny frozen object gives us a direct window into the chemistry of the early solar system, showing us the kinds of materials that helped form planets, including our own. And this brings us to a much bigger question. Could life exist somewhere like Pluto? If Pluto really has a hidden ocean beneath its icy crust, and if that ocean has remained liquid for billions of years, then it may offer the most important ingredient of all: stability. Life needs time to develop, and a stable, protected water environment is the perfect place to start. Pluto's ocean likely contains ammonia and salts, both of which help keep water from freezing solid even in extreme cold. These same chemicals could act as nutrients. And if Pluto's rocky core still gives off heat, thermal vents on the ocean floor, like the ones deep in Earth's oceans, could provide energy, just as they do here for life around hydrothermal vents. Now, to be clear, there is no evidence of life on Pluto, and New Horizons wasn't equipped to detect it. But the mere possibility of a long-lived ocean under a frozen surface makes Pluto a much more interesting place in the search for extraterrestrial life than we once believed. One researcher put it this way: if anything lives on Pluto, it would be tiny and tough, probably microbes living off chemical reactions between rock and water. These chemoautotrophs wouldn't need sunlight. They'd survive in darkness, shielded from radiation and temperature swings by miles of protective ice. Even if the odds of life are slim, the question is worth asking. Could life have once started in Pluto's ancient ocean, or could it still be forming now? We won't know until a future mission goes back to explore the ocean directly. For now, we only have a few precious days of data, a brief flyby of Pluto, and an even briefer look at Arrokoth. Yet those short encounters changed everything. Years later, scientists are still digging through the data and making new discoveries. But for all we've learned,
Pluto and Arrokoth still hold deep secrets, and many answers remain just out of reach, waiting to be uncovered by the next generation of explorers. Did Pluto have icy volcanic eruptions not long ago, and could that activity still be happening today? What exactly happens to Pluto's climate as its thin atmosphere fades and then builds back up again? Is the underground ocean touching the planet's rocky center, or is it sealed beneath a layer of icy materials like gas hydrates? How thick is Pluto's ice shell, and could there be smaller pockets of liquid water hiding closer to the surface? And what about other icy worlds in the Kuiper Belt? Are they all like Arrokoth, or is it one of a kind? These are the kinds of big questions scientists are eager to answer, but doing so will take more than just telescope observations. It will require new space missions and fresh ways of exploring the outer reaches of our solar system. Excitement is growing in the space science community about going back to Pluto. NASA has even begun supporting early-stage studies for a possible Pluto orbiter mission, not just a quick flyby like New Horizons, but a spacecraft that would go into orbit around Pluto and stay there for years, gathering detailed information about the planet and its moons. The vision for this mission includes a spacecraft that would arrive at Pluto, enter orbit, and begin creating high-resolution maps of its surface. It could monitor changes in Pluto's thin atmosphere over time, possibly observe seasonal shifts, and maybe even drop a lander or impactor to study the surface material up close. But getting into orbit around Pluto is no easy task. It's far away, and a spacecraft would need to slow down dramatically to be captured by its gravity. That's why engineers are exploring advanced propulsion technologies, like ion engines powered by nuclear generators, which are highly efficient, or even bold futuristic options such as thermonuclear propulsion. One especially creative idea involves using Pluto's largest moon, Charon, to help slow down the spacecraft. Since Charon is large and close, it could be used for a series of gravity assist maneuvers, allowing the spacecraft to reduce speed without using too much fuel. This technique could also help the orbiter exit Pluto's orbit later and head towards other targets in the Kuiper Belt. One exciting proposal outlines a mission in which the orbiter would spend 2 Earth years studying Pluto, then use Charon's gravity to break free and continue its journey, visiting another Kuiper Belt object, possibly a second cold classical object, or even another dwarf planet. If this plan becomes a reality, it would mark a major leap forward from the quick flyby of New Horizons, turning it into a long-term expedition across the outer solar system. Meanwhile, New Horizons is still alive and active. Even after its historic encounters with Pluto in 2015 and Arrokoth in 2019, the spacecraft has continued its journey deeper into the Kuiper Belt. It's still collecting valuable data about the heliosphere, the vast bubble of space shaped by the solar wind, and observing dust, radiation, and particles near the edge of the sun's influence. Scientists are even keeping an eye out for more possible targets New Horizons could visit if a suitable object comes within range. NASA has extended the New Horizons mission into the late 2020s, which means it will likely continue to report back for several more years. It may even reach the distant boundary where the solar system ends and interstellar space begins. What Pluto and Arrokoth have revealed so far is stunning. These remote worlds at the edge of the solar system aren't frozen wastelands as once believed. Instead, they're dynamic places, shaped by ancient processes and ongoing changes. From ice volcanoes and hidden oceans to slow-building atmospheres and mysterious surface chemistry, these worlds are packed with surprises. As we wait for future missions to launch, we're not simply dreaming of what might be, we're preparing for what's next. Because the next great discovery about Pluto, Arrokoth, or the Kuiper Belt beyond is already taking shape. All it needs is the right mission to uncover it.